Okay, thank you for subscribing my channel and introduce my channel to your friends and your colleagues. Let me solve some problems in fact, finding roots of nonlinear equation. The first problem is about the bisection method. So let me write the title. Problems in finding roots. The first problem is very easy because totally the bisection method is not too hard for implementation and it's not very difficult to use. Let me write let me state the problem. Consider the equation f of x equal to 1 minus x minus sine of x equal to 0. We need two things. First, I want to show that the equation has just one root in interval 0 to 1, and the second part of the problem is that how many iterations do we need to reach an error less than half times 10 to power of minus 4. Okay, this is two parts of the problem. But about the solution is very straightforward and it's very easy. First of all, note that f at 0 is 1 minus 0 minus sine of 0 and it's 1. Okay, and f at 1 is 1 minus 1 minus sine of 1. Note that if you use a calculator, your calculator should be in the radian mode for computing some problem, for solving some problems that involve with trigonometric functions. So by these two facts, we can get that f of 0 times f of 1 is less than 0, and by Bolzano theorem it gives that there exists c in the interval 0 to 1. It should be of course open because at 0 and 1 it's not 0, but if you write closed it's not problem and it's okay. So there exists a c in this interval such that f at this point is 0. Now we have to show that this c is unique and there is just one root in this interval. To this end, consider f prime of x. F prime of x is minus 1 minus cosine of x. And we know that f prime of x is less than 0 for all x in the interval 0 and 1. It should be close, of course. Okay, and this means that f of x, this means that f of x is decreasing. Okay, and this gives that the graph of f of x intersect with x-axis just in one point in 0 and 1, and this complete the proof. So there is a unique C in the interval. For the second part, it's very, very easy. For the second part, we know that b minus a over 2 power of n should be less than less or equal epsilon. Okay, here we know that b is equal to 1, a is equal to 0, and epsilon is 1/2 times 10 to power of minus 4. We should find n. It's very easy to find. You can do something like this. 2 to power of n should be greater than or equal to b minus a over epsilon, and take log from both sides, or ln, no problem. So n log 2 should be greater than log b minus a over epsilon, and this gives n is greater than or equal log b minus a minus log of epsilon over log 2. Okay, and we know that because n should be an integer number, so n should be greater than or equal bracket log b minus a minus log epsilon over log 2, and we add 1 to the right hand side because we want to be sure that the value that we computed for n is correct. Now you can put b, a, and epsilon here, so it gives that n greater than or equal log 1 minus 0 minus log 10 to power of minus 4 over 2 over log 2 plus 1. And if you compute this value, it will be in fact 4 plus log 2 over log 2 plus 1, and it should be 14 plus 1, and it is 15. So at least we need 15 iteration to get the desired error. This is the first problem. But the second one is much easier than the first one. In fact, in the second problem, I want to implement the bisection method, and it's very, very easy and just some very simple computation. The problem is using bisection method to find the root of x plus tangent of x equal to 0 in interval 2 and 2.1. It's very, very easy. You just consider f of 2. f of 2 is 2 plus tangent of 2, and this is minus 0.18. And f2.1 is 2.1 plus tangent 2.1, this is 0.39. These two gives that there exists C in interval 2 and 2.1 such that f of C is equal to 0. Now, if I want to implement the method, you can write a table like this. Let me consider n, the number of iteration, an and bn. In fact, the left and right side of the interval, and let me put it xn plus 1, which is equal to an plus bn over 2, and finally f at xn plus 1. So let me consider a table like this. Okay? Now, let me start. For n equal to 0, we put an equal to 2, bn equal to 2.1. The middle point of these two is 2.05. And if you compute f at 2.05, it will be 0.12. Okay, we know that here this is negative, here this is positive. Okay, so in the next iteration, the iteration number 1, an doesn't change, but bn should be 2.05, and the middle is 2.025, and the value of f at this point is minus 0.023. This is negative. We know this is negative. This is positive. So we should push and put 2.025 instead of an. Okay? So in the third iteration, I put 2.025 and we keep 2.05. The middle is 2.0375, and the value of f at this point is 0.0053. Positive, negative. So I should replace this one with this one. So in the this is the second. In the third iteration, I will have 2.025. We put instead of this one 2.0375, and the middle is 2.03125, and the value is minus 5.0152, and we continue in the same manner until we get the desired result. Okay, this is the in fact implementation of bisection method by hands, and of course you can use a computer and a MATLAB code for in fact simulating this method easily. If you want to see more problems, please follow my channel, subscribe my channel, and wait for the next lectures. Thank you.